Right. So for the next presentation is, of course, the H-Vision project, how industry collaboration can lead to substantial CO2 emissions savings and what it means for the storage sector. Now, for this, we have two presenters, two for the price of one. This value at this conference. And the first one is Alice Krekt, the program director at Deltalinqs Climate Program. I think Alice has over 20 years experience in port strategy and development. She worked amongst others at Port of Rotterdam and Arcadis NV. She has led teams that have made concrete steps towards investment decisions in Brazil, on inland waterway transport in Indonesia, with UN Habitat, and in several ports in the Netherlands. So she's going to be talking first, and then followed by Marcel van der Kar, who's Director of New Energies at Vopak. He's been in that position since October 2017 and been responsible for the development of projects related to the role of Vopak in the energy transition. In this entrepreneurial role, he combines understanding of technology developments, connecting with future partners, and developing stakeholder management to identify future supply chains and get Vopak to become part of new solutions to decarbonize the industry. Since September 2018, he's also been the responsibility of Commercial and Business Development Director for the region EMEA, Europe and Africa, sorry, not EMEA. Marcel joined Vopak in 1995 as a management trainee after graduating with an MSc at Delft University. Over the years, Marcel has worked in several senior management positions in the Netherlands, France, and South Africa. So I'll leave it to Alice first, who's probably, hopefully, will tell us a little bit more about Deltalinqs to start with.
Yes.
Okay, over to you, Alice.
Thank you, Mike. Thank you. Yeah, maybe that needs some clarification first to start with, because Deltalinqs is the organization that represents all the companies that are located in the port of Rotterdam. So we mainly, organize events, but also we organize projects that are of key importance to our members, so to say. And the members are, for instance, ExxonMobil, Shell, but also the container transporting sector. So about 95% of the companies that are located in the port are a member with us, and I'm leading a climate change program there, in which we execute projects. And one of the projects that I would like to talk about is the H-Vision project. And one of the members of Deltalinqs is Vopak. Of course, the storage sector is also very important in the port of Rotterdam. And Vopak is one of our members and also one of the partners of this H-Vision project that I will elaborate a little bit upon in the coming 15 minutes. Because as you would understand, I think the port of Rotterdam, it's a fossil fuel based area. Of course, linked highly with the economics of the world. So I'm very much was interested, the previous speaker who said that this balance across the world will change if you look at the energy production and the energy use. And of course, the companies in the port of Rotterdam are, of course, working on that as well to step into the opportunities that it provides. So let's start my presentation, because the Dutch government, I'm sure you're aware of that, is very ambitious if it comes to the climate, to achieving the climate goals. And what you see here in this slide is what we need to do, of course. The aim is to decrease the CO2 emissions, but we need to decrease them quick. And therefore we have this H-Vision project. We think it is, of course, you can decrease this CO2 emissions by making more renewables, but on the short term, it will not decrease the emissions so quickly. Maybe just to step up to the question that was made in the previous speech. You have, of course, renewable hydrogen made from from wind energy, for instance, it's an ideal situation, or solar developed electricity, you can make from water, you can H2 and O2, so you have then very clean hydrogen, no CO2 emissions, at least at the production site. But you can also make hydrogen at another way, and that is the way that we want to produce it. And we call it blue hydrogen. You see here a blue line, and we think with this blue hydrogen, you can more quickly, decrease the CO2 emission. And this prevents, I don't know if my pointer is also to be seen, but you see the lines here, this prevents a sort of bathtub of CO2 emissions that will still be emitted if you use the green line and you slowly decrease the CO2 emissions. So that's why we have this project in the Port of Rotterdam, and I will explain quickly about it, and later on Marcel van der Kar will explain his interest from the Vopak side, because it's also of big relevance to the transport sector, or to the storage sector. Here you see a picture that was already in a more beautiful way presented by the previous speaker, so I can be brief about this. But we think this will, for the European economy and the European industry, hydrogen will be of major importance, and all these purposes were explained earlier on. But maybe one thing to say, for the Port of Rotterdam, to be more specific, we calculated that now it's about 0.4 billion tons of hydrogen used, because it's of this more to be used in the refineries as feedstock, but we think it will be 50 times more if we look at the Port of Rotterdam area, because we want to import it, we want to use it in all these several ways. So we will really focusing on it very enthusiastically, so to say, because we also see it as an opportunity. We have a short movie that will explain very good, I think, what the project is about. So I hope that the organization can start this movie.
In order to comply with the terms of the Paris Climate Agreement, the industry in the Netherlands wants to significantly reduce its CO2 emissions. Processes that require a lot of heat will have to switch from fossil fuels to hydrogen. This means that in order to achieve the climate goals by 2030, large quantities of hydrogen will be needed in the short term. This is possible with H-Vision. H-Vision has designed a unique and distinctive process in which hydrogen is primarily produced from refinery waste gases. This works as follows. Gases are released during the refining of oil. These are captured and used as a fuel in the refining process. CO2 is released when these gases are burnt. H-Vision transports these refinery gases to a central location where they're used to manufacture hydrogen. The CO2 released during that process is captured and transported to depleted gas fields under the North Sea. The blue hydrogen produced from the refinery gases is then reused as a fuel in the refining process. This significantly reduces the CO2 emissions from the refineries affiliated to H-Vision, and also means that the factories and infrastructure are already prepared for a hydrogen economy. H-Vision's hydrogen production is based on proven technology and can therefore be scaled up to an industrial scale and deployed in the short term. In the longer term, H-Vision will continue to contribute to a climate-neutral energy system. H-Vision is ready for the fuels and raw materials transition in the chemical industry. If the sector switches from petroleum to biogenic raw materials, the refinery gases released during this process can also be processed into hydrogen. In fact, this would even lead to net negative emissions in the production process. Once the use of green hydrogen has expanded, H-Vision can be deployed to make up for wind power shortages during periods where there is less wind. The development of a hydrogen system is a joint task, both in the Netherlands and in Europe. A large number of partners in the hydrogen value chain have joined forces in H-Vision to initiate this process, but there is always room for even more customers. H-Vision partners also collaborate on a wider scale. For example, the port and industry in Rotterdam are developing a large-scale hydrogen network throughout the port complex, and H-Vision is preparing to connect to the national hydrogen backbone. This will transform Rotterdam into an international hub for other countries in northwestern Europe. H-Vision will ensure that the industry can quickly achieve the climate goals.
So I think an image can say more, or a movie can say more than 1,000 words. So I think you can look at the movie later if you want to, but this explains a lot. I will now dive into, because it looks very simple if you look at this movie, but there are some challenges that we face before we can execute the project and start with the building of the factory. I will dive into some of the details. First, maybe this is important to say that we have a large group of companies, of organizations through all the whole chain of the hydrogen development that we have connected to our project. Port of Rotterdam, you see, is an important because they lease, or they have the land, of course, position in the port of Rotterdam. Gasunie is now the transport of the natural gas in the Netherlands, but also the 3 refineries, because we want to start with the refineries as a kickstarter for this project. Of course, the transport and storage sector in Vopak. So there are a lot of organizations involved, and of course, we try to keep all these interests that organizations have, and also the economic challenges that they face when you develop this. We try to combine this into the project. Maybe just more detail about the technique, because it's a proven technology, but there's one very special thing about it, is that we use refinery fuel gas that's emitted from the refineries. Of course, they have a sort of leftover which they now use as a fuel. We will use it to produce the hydrogen, and that is important. In that sense, you make it almost like a sort of circular project, so that is important. And in the Netherlands, also in Rotterdam, we have a CO2 storage project offshore, which is developed as we speak, and we will we'll be an important client for them. And in the movie was also explained that we have a link towards the big backbone that is developed at the moment. So if you see at the project, it is one of a major important also for the Netherlands. Here in this picture, you see the complete amount of megatons that we need to diminish in 2030 as an industry in the Netherlands, and the contribution of H-Vision is 1.3 megatons before 2030, because then we build our first hydrogen plant, and the second hydrogen plant will increase it even more. So after 2030, we have 2.7 megatons of CO2 reduction. Of course, we kickstart the hydrogen economy also in the ports because we enable the industry of the infrastructure. But it's not as easy as I explained it and as it is said in the movie, because there is a big, there is still a financial gap in the project. So we are looking for the sources and the subsidies also to support this project. It's not it will not be a cash cow for the companies that are connected to it and that will execute the factory or build the factory. But of course, you need to make a break-even project, and that's not the case yet. The infrastructure, it is a slow development. we need to have a lot of, well, we have a lot of discussion where the pipelines will be with the government also, when to start with the backbone. So it is, I think, we have an urgent issue here that the infrastructure needs to be developed quickly in order to support this project. Yeah, and maybe more to say in general, this is a one-of-a-kind project. It's technically not so complex, but it is one of the first of its kind in the area, and it has also, well, a lot of like 5 core partners and 6 supporting partners. You need to combine all the interests, and that is a challenge in the business case as well. So maybe that is to start off with. And of course, I'm a director and trying to talk to the government as often as I can about these topics, and they give us a hearing ear, so they are in favor of this project and helping it develop it. So I'm very positive that we will end with a successful business case and a positive project. But let's first listen maybe to Marcel, what he has to say from the storage side there.
Yeah, thank you, Elise, and thank you for the opportunity to speak here as well. Vopak is indeed a part of the 12 companies in H-Vision, and as a storage company, we have a bit of a special role in there. Yeah, it's good to explain it a bit more. But before I will do that, I'll take you through a few slides to explain you what our role is in the energy transition, how we see ourselves, what we think we can do in new energies. And then I'll come back at the end, to our role in H-Vision. So storing vital products with care. That is our motto as a storage company. So we store the products of today's society. We store the products that are crucial, that are vital for today's society. That's what we do today. And as a company that's now 405 years old, we really like to do that in the future as well. So we like to store and handle the products of the future as well. And to look at our role in the whole energy transition, we see actually 3 different action lines. The first action line is to reduce our own footprint. As you all know, if you look at the CO2 emissions of a terminal, well, we have emissions, but it's nothing compared to the industry around us and the industry that we serve. But we do have a footprint. We do have a footprint on CO2. Of course, we have also a footprint on VOCs. We have clear actions there. And to reduce our own CO2 footprint, one of the things that we are doing is building solar parks and using solar foils. So to produce our own electricity in a renewable way, and then we can directly use that at our terminals. Another action line that we see is that we facilitate the switch towards lighter fuels and feedstocks. So lighter products, cleaner products, like LNG bunkering. We are investing in that. We're investing in LPG facilities. But you can even clearly explain that the investments that we do, for example, to import diesel and gasoline in a country like South Africa, where it is then possible to import cleaner products. So it's maybe not the step towards the renewable products that we are focusing on here today, but it helps at least to make the first steps. So that part is often forgotten in our industry. So we are already contributing there. The last part, the right picture that you see here, is the development of infrastructure for new solutions and new energies. And that's where I'm focusing on, and that's what we are looking at also more today. Because we see if you look at that transition, if you look at those new energies, those new products, it is a lot about technology, it's a lot about production, it's a lot about demand, which is all very important, very true. But what we also see is that you need the right infrastructure. There is a demand, there is a supply, and it needs to be connected. And we think that we as Vopak, actually I think that we as a whole sector can play an important role there. And we need to play an important role. And as Vopak, we have a whole network of terminals around the world. We know how to operate them. We have the infrastructure knowledge, but we also have the knowledge of supply chains, and we have the knowledge of the different markets. If we look at the markets of today, we like to understand where the supply is coming from and where the demand, how the demand is developing, and how that will affect actually the flows, and how that will affect the storage needs of our customers. And in these new products, in hydrogen, that's actually very much the same. So you also have their demand, there's a supply. It's much more unknown, it's much more uncertain, but it will develop. We have clear confidence in that, and we fully support the slides as also were presented by Alexandru. And as an infrastructure company, as a storage company, we can facilitate and even accelerate the energy transition. And we see that role in 4 different buckets, in 4 different areas. The first is hydrogen. The second one is carbon dioxide, so the CO2, the collecting, storage, bringing it to the subsea storage facilities. That is a whole new supply chain that really needs to be developed. The third one, that's the most left here on the picture, is the electricity storage. We see an opportunity there for us as a storage company to store electricity in liquid. So then you have large flow batteries to balance the electricity grid as well. And the fourth area is the new, more sustainable feedstocks, where we see recycling options in the industry, and that will become important in many parts of the world as well. So if I zoom into hydrogen, this is a different picture, but I think it's very much the same message that Alexandru showed earlier, but it really connects the full supply chain. So you see on the left side the production of renewable electricity. You have a whole electricity grid, and you can make the connection between electricity and hydrogen, and then connecting hydrogen to the different markets. And that is really what we see as the strength of hydrogen. And of course, there's a small bubble in the middle, in the top, where you see that hydrogen can be imported in as well. So we see a very clear need for hydrogen to be produced locally, but also to be imported from other regions. And then we look at the same areas as already presented before, that you can import it from the south of Europe or the north of Africa or Middle East or Australia or Chile, and you can supply it then towards the larger demand areas like Northwest Europe, but also Singapore, Korea, Japan, and even the United States. So we see a clear role there for hydrogen to be imported. And if you want to import hydrogen, then you need to, of course, understand how to import. And there are different options, different ways. First, we see the pipeline option. The pipeline connections are possible. You can use the pipelines that are now used for natural gas, convert them into pipelines for hydrogen. But as we all know, constructing pipelines, really long distance pipelines, subsea pipelines, takes quite some time, and then you have a point-to-point connection. So it is a good way to do it. We see it as part of the solution, but we also see the maritime connection as very important. And then we see clear solutions on the top. We really look at liquid hydrogen, so the liquefied hydrogen at minus 253 degrees. You can ship it, you can store it. It's very comparable to LNG, but it's a very capital intensive solution and extremely cold. So you need to put a lot of energy there, but it can work. And for some of these markets, as you see here, we see it can work. The second solution we look at is ammonia. Ammonia is a technically very interesting solution. It's a product that contains a lot of hydrogen. It's a product that you can store, that you can ship. We store it ourselves in 5 different terminals, so we know how it works. But we also know that it is very toxic. It's a product that needs a lot of extra attention in port areas. It is very well possible in industrial areas. It's very well possible. But to really connect it to all the end markets, that will also be a challenge. So we see it as a good option as well, as a second good option, but for specific markets again. And then the third solution we really see is the liquid organic hydrogen carrier. That is the connection you make between a hydrogen molecule and a molecule like an oil molecule. So it's like a lamp oil type of molecule, and you connect the two together, and then you can store and transport it actually in the existing vessels, in existing tanks, in existing pipelines. And of course, that brings in a lot of advantages. That makes the transition quicker. That makes the transition safer. It's easy then to transport it all the way to a demand center. But it also makes it interesting for different markets to use. But also this solution has disadvantages because you need to disconnect the hydrogen at that location where you really need the energy. So that is, that's part of this of the advantage, that it's a safe way to store and transport. But the disadvantage is that you need it then in the end place where you need the energy. So yeah, that could be also a good solution for several markets. And we see those three developments, of course, next to the biofuels connection, the synthetic fuels, and the methanol. But for the real longer future, we see those three as real good solutions. And we are working on projects on all three of them. And then we're importing. But I also already mentioned, we think that we have to embrace all solutions. So also the solution of H-Vision. And that's a long introduction, I know, but now I come back to the same picture as you've seen in the short movie, is that we think it's very important also to connect to blue hydrogen, to make the connection between the emissions of today and really reduce large scale, very quickly in the coming years, large emissions of CO2. And that can be done by storing the CO2 under the ground. And that can also be done in this connection, as was just explained, by decarbonizing the refinery refuel gas. And by doing that, you're already setting up the infrastructure that is needed for the future green supplies. So if you then in the future build import terminals in any form, one of the three forms, as I mentioned, or even connection by pipeline, then you can already connect to this system. And then you have already industrial use of hydrogen, of blue hydrogen, and you can add the green hydrogen to it. And you can then further develop the markets. Because what we see is that there are so many things you need to develop at the same time that it really helps if you can do things in parallel. So waiting for the development of the infrastructure for hydrogen in a port will only delay the whole development. So we say we need to accelerate. So let's do it already now. Let's do it with the locally produced hydrogen, the locally produced blue hydrogen, make it blue, really start combating the climate change immediately. So that's the reason why we are part of H-Vision. We learn a lot. We learn a lot about the different technologies. We learn about the corporations that are needed. And in this way, we really think that we can facilitate the whole transition. So that was the part I wanted to share with you. So back to you, Mike.
Thank you, both Alice and Marcel. Thank you for your presentations and about H-Vision, very interesting looking project. Okay.